There you go. Well, let me just say this morning that we're going to talk about a very different topic, the potential to have dramatic breakthroughs in cures. We're very fortunate in that we have Jim Greenwood, a colleague of mine who'd been a member of Congress when I was there and who has been the head of BIO, which is the organization which represents companies that are trying to use biological breakthroughs in order to have new drugs, new approaches, new solutions that are really saving lives. And so Jim and I are going to chat for a while. We're going to take questions about cures and what's happening. And let me just start with the scale of the science and the change that you see coming down the road and what that means for everyday human beings.
Yeah, so actually I like to start this by looking back and saying, think about where we were just a few years ago. I mean, in the last 25 years, we've reduced the incidence of cancer, death from cancer by 25%. Think about AIDS, which was a death sentence until very recently. Today, if you're a 20-year-old and your doctor says you have HIV, you'll probably live well into your 70s. Think about what vaccinations have done in terms of just eliminating whole classes of diseases that plagued millions and millions of people around the world. So what we've accomplished so far is astounding. Going forward is going to be miraculous because now we're able to understand disease at the molecular level, at the genetic level, at the cellular level, and do things like turn our immune system against cancer. Our immune system works very well against bacteria and sometimes viruses, but to be able to turn our immune system against cancer, because cancer has evolved to fool our immune system. And now we're figuring out how to fool cancer and actually use our immune system against it. So that immunotherapy is incredible. Gene therapy, we're going to actually be able to, I saw an instance where a boy had a disease of the eye that caused him to be blind pretty much from birth. He wasn't completely blind, but he bumped into things. They gave him an injection of a cell therapy in his eye. He was shooting skeet a few years later.
Wow.
Yeah, no limit.
So you see this sort of expanding horizon of new breakthroughs that directly affect people's lives.
Yeah, I make the claim, and maybe it's hyperbolic, but I don't think so, but I think it's accurate to say that there is not a disease on this planet, and there are something like 7,000 of them, that we will not be able to treat, cure, and eventually prevent using biotechnology. There's no scientific reason why we can't get there.
Just for most of us who are not expert in this, explain biotechnology as a concept, because it's really a big breakthrough of the last 30 or 40 years in what science is enabling us to do. So how is biotechnology different, for example, from the traditional pharmaceuticals?
So biotechnology is really just using life processes, using what we've learned about the human body, what we learn about animal bodies, what we learn about plants, and turning that knowledge into valuable things, be they medicines, be they new ways of enhancing agriculture, be they new sustainable fuels and materials. So it's just using life. The big difference in medicines, though, is when we think of pharmaceuticals, we think of what we call small molecules. They're chemicals. And chemists blend the chemicals and they stamp them into pills and we swallow them and it has a salutary effect. A biologic is something completely different. A biologic is created inside a living cell, and it's what we call a large molecule. So if a small molecule is a dime sitting on this table, a large molecule is the table. I mean, it's a huge and complicated, usually a protein. So, for instance, if you have a mutation, if you're born with a mutation that prevents your body from producing a certain protein, okay, we can clip out a little segment of DNA from a person who doesn't have that mutation, a healthy person, and insert that into the genome of a bacteria, and then multiply that bacteria by billions, put them in a big vat, and they'll sit there and they'll pump out that protein. And then we strain that out, essentially, and inject it in you, and you're no longer affected by that disease.
So, I mean, I think the thing that's hard to understand here is you can increasingly do miraculous things. I mean, things that in 1900 would have seemed like they were hopelessly impossible. But these are really big, complex processes. I mean, none of these things are cheap, and none of these things are, and this is one of the things that confuses people. And it takes, I think, an estimated $2.6 billion to get one new drug to market. So you both have to invent this, understand it, test it, get it through the government's own regulatory agency, the Food and Drug Administration. And all of that slows down the invention of new cures and raises their price.
Right. So here's something wild. The Biotechnology Innovation Organization that I have, we have about 1,000 members. 90% of biotechnology companies fail.
Wow.
90% of the projects that they start to fight a certain disease fail. Okay, and of the ones that succeed and actually get approved by the FDA, only 20% recover their costs. This is one of the most scientifically complex, difficult things to do. It's one of the most expensive things you can do. It makes going to the moon look like a walk in the park, and it's extraordinarily risky. So what does that tell you? I mean, we need to do this. We're excited about doing this, but it's very hard and it's very risky. So the economics tell us something about that. It's pretty basic: high risk, high reward. So when people say, God, that cancer drug's pretty expensive, yeah, it has to be, because look at those failure rates, and we've got to figure out how to make enough money on that before the patent runs out, so that we can invest in the next stage.
So you and I both helped double the size of the National Institutes of Health at a time when we were balancing the federal budget,
Right.
which is a great example of setting priorities. But, and a lot of people say, well, gee, can't the federal government do it? But the truth is, there's $4.50 spent by the private sector taking the science from NIH for every dollar the NIH spends developing the science. So the actual process of getting it from the laboratory to your bathroom cabinet for you to take in the morning is really a long process and requires very specialized people. Folks, I think sometimes people get confused and think, well, why can't the government do all this?
Yeah. You know, when you and I were in Congress, when somebody would wheel a child into my office and say she's dying from a disease for which there's no cure, because I didn't understand the business that well, my first reaction was, I'm for more NIH money. And I am. And you and I, as you said, were there when we doubled it. But NIH does a very specific thing. It invests most of that money in academic centers, universities, and they're doing basic research. How does a cell work? How do the genes construct themselves? Just understanding the basics. That then can yield information and knowledge that we can use to turn into medical breakthroughs. But that's all done outside of the public sector in these little companies all over the country and all over the world. And that's where the risk is taken. That's where the research, the development goes on, and that's what ultimately brings products to patients.
But when you look at it, what do you think can be done over the next 4 to 8 years to accelerate? I mean, as I get older, I get more and more interested in getting these things. Stuff that when you're 20, that's a long way off, but I'm 73
I'm sure they'll cure
now.
it before I'm
That's
70.
Right. That's right. So what do you think can be done to accelerate the development and delivery of new, better cures?
So the way I look at it is the thing that's accelerating it is just the pull of all of these patients who are crying out for help and for hope. And the thing that's accelerating it is the fervor of these young scientists and these entrepreneurs who are committed to this gargantuan task. I'm more worried about it being decelerated. And as I say almost every day of my life, the only thing that's going to stop us from being able to cure all these diseases is bad public policy. And there's a lot of that going around, unfortunately. And I understand the cost of it. When you have a drug that costs $100,000 or $200,000, and private insurers are paying for it, or the government's paying for it, there's sticker shock. And a short-sighted view says, whoa, we got to control that price. Well, you can do that, and every drug that we have on the market today will be there cheap. You won't get any more. And if we disrupt this innovation cycle, starting at NIH, going through these small companies, going through the FDA to patient, we disrupt that cycle, then these miraculous things that the science is pointing to just won't happen. That would be a crime.
I mean, I look at it from the standpoint of cancer, which you mentioned, but also from the standpoint of heart disease, diabetes, Alzheimer's, depression, schizophrenia, and all the different kind of things. We're right at the edge of breaking through. And Robert Simmons just wrote it and said, what regulations need to be eliminated, and why don't we partner with European drug makers who put drugs in the market at a faster rate?
So I'm going to say something a little controversial here. I'm not focusing day to day on eliminating regulations. We have a law in the books called the Pharmaceutical Drug User Fee Act, and what that consists of is the companies that take their applications to the FDA pay a sizable fee, about $1 million, and that helps the FDA to have enough staff to be able to understand the science and to review our applications in a timely fashion. And in exchange for that, we negotiate with them how fast they're going to do this. And we've made a lot of progress with the FDA. I'm pretty pleased with the FDA for the most part. What I'm really worried about, and I'm reiterating this, is the price controls. What I hear from presidential candidates, what I hear from congressional candidates, what I hear from President Obama all the time for the last almost 8 years, is that we've got to lower these prices artificially, and that's the thing that scares me.
Because, as I understand it, if we in fact got the kind of price controls they want, you would literally cut off the future.
Oh yeah, I mean there would be, this money. You talked about the $32 billion from NIH times 4 in the private investment community. Those, whether they're venture capitalists, whether they're people who are in the stock market, whether they're the California Retired Teachers Association, they're not placing that money in these companies because they want to cure cancer or Alzheimer's or diabetes. They're looking for return on investment. And as soon as you start to change the rules of the game, which threatens the return on investment, that money is just going to go somewhere else. And we saw when there was this awful guy, Shkreli, who his company was a member of BIO for about 6 months. As soon as we saw what he did, they were no longer a member of BIO. But when he did what he did, which is the outlier, Hillary Clinton tweeted something, the biotech stocks dropped 20%, and they haven't recovered since. So it doesn't take very much to shake the confidence of these investors and drive money away from innovation.
I think we've had, over the last 20 years, like 3 or 4 different times where a politician would say something and you would literally see billions and billions of dollars leave the market, which meant the money wasn't there for research.
Right.
I mean, so each of these incidents not only drives down the price, but it drives down the rate of innovation and the rate of investment.
Well, Bill Clinton did this famously when he first took office.
I think at the time they sort of learned it. Robert Waddell says, what role should the FDA play in our current innovative environment? And as you said, you feel like they're really evolving in a positive way.
I think that they have evolved. The biggest challenge we have at the FDA is having enough personnel there and enough well-skilled personnel. The federal hiring process is very, very cumbersome, and there are limits on what you can pay people. And so we are constantly going to the FDA and saying, what are you doing to enhance your HR? They had a very, very lousy HR system. They were slow to announce positions. They were slow to take applications. They were slow to process those applications. And people were sitting around for months and months and months saying, I want to work at the FDA, but I guess I can't, and I'll go take another job because it's too slow. We're making tremendous progress there now.
Well, and isn't that compounded because the speed with which the science is changing means you've got to have some program. I remember working with Andy von Eschenbach when he was at the FDA to try to build sort of internship programs so that you could get people to upgrade their scientific knowledge, because if they were in graduate school 25 years ago, the whole structure of what we now know has changed so dramatically that they're not in a position using that knowledge to really evaluate what's coming through the door. So you have to have a constant improvement even in the personnel who are already there and experienced.
That's exactly right. And so the science is galloping along, and you have to have the people with the right expertise in the FDA to understand that. And that's why it makes some sense. Now, people will be hesitant, people are cautious about individuals moving from government to private sector and back and forth and so forth. But actually, that's a healthy thing here, because if somebody is in one of these innovative companies and then goes and spends some time at the FDA, they take their scientific knowledge with them.
Yeah, I mean, it seems to me, as long as they are not making decisions about their company,
Of course not.
that it is a tremendous infusion both ways. I mean, you almost want the FDA government employees to go and do internships in companies to understand the dynamic, and then you want people from the companies to go and try to apply the regulatory law. So that, and partly just because particularly as we evolve, for example, with brain science, that involves such a totally different range of knowledge than other kinds of traditional medicines that you really have to rethink what you think you know in order to deal with it.
Well, the other thing that has become a problem is the administration was so tough on any travel. And you and I know there were tons of abuses of federal employees going on junkets and all of that. But FDA reviewers need to go to scientific conferences. Those are not usually junkets, but they need to be able to go there and listen to the most recent papers and network with these scientists.
Yeah. Matt Gordman wrote, from your standpoint, what's the one disease we're closest to finding a cure?
Well, I talked about cancer and immunotherapy. Of course, cancer is not a disease. Cancer is hundreds of diseases, and you and I could have what seem to be the same cancer, but we have different versions of it. So it's more personalized than we thought. But these breakthroughs in our ability to teach our immune system how to outwit the cancer cells, so that they can go and destroy those cancer cells, is really moving at a quick. Jimmy Carter, had stage 4 brain cancer, which by every precedent should have killed him. He took this new drug from Merck, and he's cured. I mean,
Wow.
It's gone.
So they were able to actually eliminate brain cancer. That's pretty astonishing.
I'm sure he's technically in remission, but
Yeah.
he's the tumors are gone.
It's a lot better than it would have been prior to the new drug.
Yeah.
So along that line, let me say to everybody who's watching, I'm doing an article today, and there's an article in the Wall Street Journal this morning on this whole issue, and my newsletter today, which people who want to can get it at GamishProductions.com, is going to be on this topic. But if they want to know more about bio and what you do and what you're all about, what's the right website, and what should they do just to learn more?
www.bio.org is our website. It'll take you to a host of other websites that we have. We have a website about the insurance industry, which we didn't get into, but I'm going to take 30 seconds anyway. One of the problems we have, and I talked about how a lot of the politicians are reacting to pricing. One of the problems we have is that insurance companies are increasingly shifting the burden to the patient. So if a drug costs $10,000, and you go to the drugstore and the druggist says, well, we need $3,000 from you. I mean, nobody's walking around with $3,000 in their wallet, and so for most people, for almost everybody, that's a shocking price to pay. Well, you can get mad at us and say, well, why does that drug cost, $10,000? Well, cut the price in half, it's $5,000. Now you still have to pay 30%, according to the insurance companies frequently. So now you're at $1,500. That's still too much. Cut it by 2/3, and eventually, if our prices were lowered like that, innovation would be gone. So we really have to take a look at the insurance industry and saying, why are you pay almost 100% of hospital costs and doctor costs, but why is it that when it comes to medicines that are really the part of the healthcare system that saves money, why are you putting the burden on the patient?
Good. So I encourage people to go to
www.bio.org.
There you go. Great. Thank you.
Thanks, Newt.
Good.